Dear viewers, today we are going to discussing about earthquakes. We have studied the formation of earth, inclusion of different branches of geology. We have seen different formation of faults, structures, again lineations. Then slowly we are coming into the earthquakes. What will be happen in a earthquake? How we can identify the earthquakes, where it will be occurred, how they are occurred. Let us see. The sudden and tangential movement which are occurred inside of the earth, and again the earth surface which is producing the tremors in a rocks. That means suddenly movements and shakes will be occurred within the earth's crust. Such sudden movements which are happen under the surface, which are known as earthquakes. Yeah, how it was generated, the earthquake word. Before going to that, we need to know the earthquakes, the formation of earthquakes. An earthquake, it is known as tremor and trembler, which is shaking under the surface of earth and resulting the sudden releases of waves within the earth which is having a lithosphere content. Those lithosphere content, it is creating the seismic waves. So that these seismic waves are moved and getting the vibration which are horizontal, or maybe it is vertical also, depend on their intensity. Again based on the focus point and from the releasing of these seismic waves from focus as well as from epicenter and again hypocenter, these waves which are released horizontally and as well as vertically. It is very different, which are having the very different earthquakes, and sometimes maybe which are travel into the solid, and some of the waves which are travel into the liquids. So that within a within a few seconds the area maybe it is going to be collapsed. The finally Herodotus plain and it was introduced and found these earthquakes ago, almost 2500 years ago, and other historians and philosophers mentioned about these earthquakes. Then how the earth it is made up of, that is also very important to us. Yes, we know what we have studied in others. Then the first one, it is a solid inner core it has. Yes, we know that the core it is one, it is outer core, and one more it is inner core. So in a inner core, maybe it is a solid inner core, sometimes maybe it has like that, or sometimes maybe it is a molten outer core that is also having, or some of the places which are having the thick and maximum it has a solid mantle, and it is occupying almost of 84 percentage of the earth's total volume. Comparatively, if you see in a earth's crust, it is comparatively little bit, it is a variation it is also having, that is maybe between 5 to 50 kilometers of thickness. There we will see the tectonic earthquakes. Other seismologists have been classified 3 more earthquakes. What are those? Let us see. One, it is a volcano, second one it is a collapse, and third one it is a explosion. In a first volcanic earthquakes, it is related with volcanic activity. I mean it is associating and connecting with volcanic activity. In second case, that is collapse, which has happened in a small scale level or a small scale level. The earthquakes which is result from the subterranean areas, and the area it is a collapsing of convents and as well as these type of collapse we see in mines also. Third one, it is explosion. The explosives almost it is related with this one, like maybe it was happened by the chemical and the nuclear incidents. How we can record these earthquakes? Yes, we can record with these earthquakes. First, we will use the instrument based or instrument we will use. The first instrument was made able to record only the fact there had been an earthquake. I mean, it is not furnished information regarding that instrument. Again, it is measuring the velocity also with that. Yeah, definitely depend on that velocity and intensity level we will record, and then what it is that instrument we will use. At the first time I almost it is 136 AD Anno Domini at the time by the Chinese. They were made seismoscope. By this seismoscope they were recorded and measured the waves and the intensity of earthquakes. What it is the principle behind of this one? Yeah, actually we have heard about a seismograph. The seismograph it consists of a heavy mass suspended like a horizontal pendulum was fixed with that one. Then again the stand which is fixed into the surface internal of the surface. When I mean surface means ground level, below the ground level it was fixed. Then suddenly if it is getting the shocks within the earth or maybe small vibrations also it will be happen within the earth, it is absorbing the stand, it is absorbing, then it will be moving right and left side or front and back, or due to the shakes it is moving. So, then automatically the horizontal pendulum whatever it is fixed with that one, then it is writing on that one, writing on a slate. So, that and again it is creating some graph lines also. Based on that lines we can identify what it is the intensity or what it is the velocity, we will be identifying that. Then how it will be working? Yes, it will be working. Actually it has a small mirror attached with the weight. The mirror it is useful for to reflecting of objects, and it has a one light in a beam, and whatever focus it will be release the waves internally, and it is absorbed by the stand, and immediately it will be sent into the beam of light. So, the beam of light it is attaching the paper paper, and along with the one photograph, that paper means here photographic paper, it will be attaching with that one. Along with that, the what I told you, that is a horizontal pendulum, it will be moving front and back, and it has like a pencil cone shape will be arranged with that one. Then it will be writing on that paper. While it is getting the these shocks, the stand it will be moving front and back, then the pendulum it will be writing on a photographic paper, look like in a graph sheet. So, that we will identify with using of that one. While rotating the drum carries its the paper, it is marking, and the paper it is writing, and all those it is giving the drawing sheet. So, it will be continuously, the recording it will be continuously. So, that based on this we will find out. Then seismograph record, it is what we are calling, that is actually we will call that is as a seismograph record, it is called as a seismogram, it is called as a seismogram. So, is it required any time? Yes, definitely it is showing the required time, and again it is showing the exact time whatever shocks were happened, or whatever shocks were occurred within the surface. The time it is also I mean it will be mentioned on that one, and along with that intensity of shock, and it is recording, I mean it is recording by this seismogram. Then the science it is determining, the science it is determining what it is the size of that earthquake formation, what are the characteristics of earth formation. These are all we will study in a seismology. That means seismology, it is a science, actually it is seismology, it is a science. Previously what we have seen, petrology, mineralogy, like hydrogeology, like sciences. This is also seismology, it is also one of the science. It is useful for study of earthquakes, different types of seismic waves will be generating from that one. So, that as per that we will see here. So, that the science, it is called as a seismology. Then the detailed record of an earthquake, which is made on an instrument, it is called as a seismograph. It is called as a seismograph. Why we are calling this is a seismograph? I told you it is it is attaching with a graph paper, and like a pencil or a pen like material object will be there, it is attaching with that one. Then again on a graph paper it is a recording, while it is getting the observations, or while it is getting the shocks, the stand it will be moving. At the same time the pendulum, it is moving front and back. The pencil, it was attached with that one. Then on a and graph paper, it was fixed with that. Then it was fixed with that, and again while it is moving the stand, the pendulum, it will be moved front and back. Then automatically the graph like structures will be made on that paper. So, it was associating with a graph, and the graph, it is giving the information of a seismic waves. So, that is the reason we are calling it as a seismograph, and it was invented first time in Italy 1841. Here the record, whatever it is associating with this one, the record, it is called here seismogram. The seismogram means here seismic waves, it is a recording by this one. So, that is why we are calling it as a seismogram. Various earthquakes, earthquake waves, we are talking about that. So, suppose if it will be suddenly the shocks will be generated, then we do not know, they have a different intensities. Within a fraction of seconds we will see it is getting the collapse, but how it will be happen, how we can expect, what type of waves which are having. So, when suddenly the earthquakes occur, it is releasing huge amount of energy, everything it is relating with a huge amount of energy must. Without energy it will be not move, even though if you wanted to walk, definitely we need energy. So, like that similarly here also the waves means it will be working on energy levels. How it will be regenerating that energy? The waves suddenly they are generating during the sudden crustal disturbances here, that is main word, crustal disturbances beneath the at the surface. So, the movement of these waves we are calling seismic waves. The movement of waves we are calling seismic waves, and there are 4 types of waves we will identify in this one. One, it is longitudinal waves, and second one it is shear waves, and third one is relay waves, fourth one it is love waves or L waves also we are calling that is. So, longitudinal waves, the longitudinal waves, it is consisting of alternating of pulses, again pulses of a compression of a refraction acting and momentum. The energy it will be releasing from the different faults or different structures, the waves will be generated at the time. These waves we know that is P waves. P waves means here primary waves. Later I will tell you about that primary waves. Then second one, it is shear waves. In a shear waves, it is a oscillating movement it has oscillating movement, and at the same time it is creating the right angles, and that means it will be moving from left and right at the same time, while it is coming towards a right angle, then the energy it is released to the right direction of a wave. So, that the waves will be travel towards right side. So, These shear waves, secondary waves we are calling, so that which waves are known as a S waves, which waves are known as a S waves. Then third one, it is a relay waves. These relay waves particles which are having the very slow motions, and it has a circularly they will form previously to, or one it is generating, or one it is moving from left to right angle, it is maintaining second one, and the first one it is horizontally they will move. But here vertical, it has a vertical section, so that the vertical section round and round and round circle motion which are having, so that the vertical planes will be created here. And final one it is I mean fourth one it is L waves. Here L waves are love waves which are most particularly oscillate along the horizontal plane, and also it is creating the right angles, and along this right angles the waves will be traveled. So, here love waves and relay waves which are known as the surface waves here. So, sometimes these waves we are calling as a L waves also, we are calling as a L waves also. So, here what we have seen, one it is the P waves, second one it is S waves, and third one means here relay waves and love waves, both together we are calling here it is as a these waves are as L waves. So, what it is the direction and travel? P waves always travel with a great velocity, which are having a very great velocity compared with S waves. And what about S waves? S waves also compare with the L waves, they move very fastly. They move very fastly. In secondary waves or shear waves, these are all. Then L waves are, they will move very slowly, and along to the surface, horizontally they will move. So, that these waves are called the surface waves. L waves are called the surface waves. Among these P waves, S, L waves, finally the P waves are very fast than compared to the previous two one. Then intensity, how we can measure the intensity? Every material, I mean every object here, it has its own intensity. So, that the intensity how we can measure? Is it showing any impact on earthquakes? Yes, definitely it is showing the impact on earthquakes, and how we can observe this. These are all will be recording on a seismograph. What I told you, it is a recording on a seismograph. And who was introduced this seismograph? The seismograph, it was introduced by the seismologist of Rossi and Ferrel from the Italian. So, that it is known as a Rossi-Ferrel scale. That is a old one. Later the updations was developed, and then the latest scale was introduced by the Richter. So, that now we are measuring that is on richer scale. Recently also we have seen in Indonesia. Indonesia, we got same earthquakes approximately. It was found recorded nearby the 6.5. It is giving the major and more destroy in that areas. Almost all the recent earthquakes which are recorded, and we are using the Richter scale only. Then we will classify the earthquakes also. How we can classify these earthquakes? The earthquakes are classified depend on their disturbances of area. Disturbances of area means the energy where it is going to be, I mean where it is generating in a internal of earth. The point we need to identify, the point it is called as a focus point, and then from this is a focus point, the particular focus point we will call that is a center. The center, it is known as a hypocenter. It is known as a hypocenter. Then one more word it is also there, the vertical projection, the moment of a waves which are traveling and projected on within the surface. the place it is called as a epicenter, the place it is called as a epicenter. Now, you see here hypocenter, it is showing in a down now, where it is a fault, it is occurred there. Then the fault, it is a structure, it will be moving towards right side and to the top. Then the focus point will be generating there, the focus point will be generating there, and from this is a focus point, the waves will be different types of waves were generated at the time. Then again some of the waves they will move horizontally, or some of the waves they will move vertically. Then again here I told you just now P waves and F waves, if both they will travel at the same time, because of depend on their intensity and energy, they will move very fastly. Then within a fraction of a seconds, within a seconds they will collapse and destroy the different areas. That based on that, the area it is going to be destroyed. Then what it is required and where it will be generated, these hypocenter point or epicenter point, what it is depth it is required to us. Actually, there is no earthquake has been recorded till now. The focus from the focus point, that is maybe nearby the 700 kilometers of a depth it has. More than sometimes maybe it is originated at the nearby the 300 kilometers, or sometimes maybe the deeper of 300 kilometers. We are calling such type of earthquakes are called as a deep focus earthquakes, deep focus earthquakes, which are originated nearby the 300 kilometers of a depth. The second one, it is if the focus point maybe sometimes it is generated nearby the 70 to 300 kilometers. Such type of earthquakes we are calling intermediate focus earthquakes, intermediate focus earthquakes. These are will be generated nearby the 70 to 300 kilometers, between that area. The earthquake with focus again sometimes maybe it is less than 70 kilometers, less than 70 kilometers, which are known as shallow focus earthquakes. Shallow focus earthquakes, maximum of the area or majority of the earthquakes will be happened here only. I mean, in this category, from this category maximum we will get shallow earthquake. What are the reasons? Can we expect any reasons for these earthquakes? Yes, definitely we will expect some of the reasons or main causes also we will have. Earthquakes which are originate during the various due to the various causes, those are maybe it is a faulting formation or a volcanism formation. Structurally, based on the structurally first, then after that volcanism due to the volcanic activity, and geomorphological features also playing the very important role in the generation of earthquakes, and which are leads to cause collapse of different formations. The majority of earthquakes which are origin within a 16 kilometers of a depth, 16 kilometers of a depth. So that what is happening, if it is more energy, if it is released from that one, then automatically within a fraction of a seconds those P waves, primary waves will travel vertically at the time, vertically they will travel. Then if gaps will be maintained or solid particles, if it is attaching with that P waves, then rapidly they have a capacity, rapidly they will be collapsed. So, it is a main reason. So, previously what I told you, that is a 70 kilometers, below the 70 kilometers maximum of earthquakes will be occurred. This is also similar to that, but here I mentioned only 16 kilometers. You just we can imagine what it 16 meters means. It is a less depth, but at the same time it is releasing the huge amount of energy at the time. So, that is a reason within a fraction of seconds the area it is going to be collapsing. Then Professor H.F. Reed carefully he carried out his studies on earthquakes in San Francisco. He proposed a new theory sometimes maybe the area which is having the plates we discussed in previously. So, along that the plate boundaries which are having the elastic property. So, the elastic property as per that the waves which are generating and they will move constantly, they will move constantly. So, the edges of these plates side by side they will come, side by side they will come in a fault zone, in a fault zone. Along that the fault zone the plates will be slipped, the plates will be slipped. So, that is caused by this one. Again the force it will be also the force of a moment finally overcome the this friction. Suddenly some of the sections which are having the crust material and suddenly which are getting the breakup and displaced also, displaced, and then it is releasing the huge amount of energy at the time. This all will be occurring in earthquakes. Sometimes it is some referring as a tectonic earthquake. Now, you see here this is a picture, the strike and slip fault. The first one it is a strike and slip fault. Along the strike the fault it is going to be forming. So, that this is one cause there in the mid of the area, in the mid of the area the waves were generating. So, these waves are transporting or moving along the fractures, along the fractures or along the boundaries. So, that which are creating the disturbances in a internal of the surface. Now, it is appearing in or we will see in a strike slip fault, and next one it is a reverse fault. In a reverse fault what is happening, the downside whatever it is the fault or formation it will be come towards top, it will be come towards top. So, there may be also chance to generating these waves. And third one it is a normal fault. In a normal fault of this case, just you see this one, in a fault the tectonic momentum or the plate it will be go down, go down. In a reverse fault it will be come up, in a normal fault it will be go down. Then when it is coming towards down, the friction it will be created between the two faults, the friction it will be creating the two faults, there the energy will be generated, there the energy will be generated. So, in a reverse fault maybe it is a huge amount of energy it is releasing, and again in a strike and a slip fault also, but whereas we compare with a normal fault it is creating the less amount of energy. So, according to these theories, the sudden or shifting shocks will be occur along this fault. These earthquakes are due to structural disturbances. Yes, definitely. What we previously discussed in a strike slip fault or in a reverse fault or in a normal fault, those are all the structural features which are getting the disturbances, and the energy it is going to be released from the hypocenter and epicenter also. The tectonic earthquakes are a result of the tectonic movements, it is showing the tectonic movements, and also earthquakes are also caused by the volcanoes also. The movements of magmas and other gases which are creating the disturbances in a internal surface of earth. So, that is the reason the volcanic activity or volcanism also it is one of the major cause for that one. Then submarine earthquakes also. In a submarine earthquakes which occur under the sea water, that means under the sea water means what is happen under the oceanic crust. Under the oceanic crust again we will get the structural formations or tectonic plates which are moving and rotating. While they are rotating, sometimes what is happening, they are getting the collision. So that due to this is a collision to the one plate to the another, there the energy it is released. So the sudden shocks will be created though there. So automatically the disturbance will be occurred there. Those type of shocks we are calling those are tsunamis. Tsunamis, the correct word it is for that, tsunamis will be creating or created under the oceanic water only. Earthquakes again distributed along the two major belts. One it is namely Pacific ring, and second one it is Indonesia, Andaman Nicobar and island, and again nearby the Burma area. So overall the earthquakes which are having are how they will be generated means sudden shocks and sudden movements will be occur within a within the surface, I mean earth surface. And then there are I told you there are three types of the waves were generating. Three types of the waves were generating. One it is P wave, second one it is S waves, third one it is L waves. Based on these intensities, we will calculate the earthquakes movement and how they are generating with using of seismogram and Richter scale.